Hello, we are Team 16. We will be providing an overview of what cloud computing is, how it works, and different protocols used in cloud computing. You're probably using cloud computing right now, even if you don't realize it. If you see an online service to edit documents, watch movies, or store pictures, it's likely that cloud computing is making it all possible behind the scenes. Cloud computing is the delivery of on-demand computing services from applications to storage and processing power, typically over the internet on a pay-as-you-go basis. It uses a network of remote servers hosted on the internet. So how does cloud computing actually work? The front end represents the computer and other end devices that you as a client use. This enables you to connect to the cloud using interfaces such as a web browser. All the information and data uploaded on the cloud is stored in a data center with powerful machines. These machines contain rows and rows of data that you upload and provides users access to the data from anywhere around the world. Now we will be exploring 4 different types of deployment models: private, public, community, and hybrid cloud. In a public cloud, services are delivered over a network that is open for use by anyone. It's an accessible cloud environment owned by a third-party cloud provider. So what are some advantages of public cloud? Capital and operating costs are shared between multiple users. This is the most economical way to access the cloud. It also gives users access to new technology without high development and implementation costs, and provides immediate access to data storage and other services as and when they're required. Some disadvantages of public cloud include offering far less scope for customized security options. Customers have no control over the physical location of their infrastructure and data. It's good for small businesses and startups to reduce overhead and expenditure costs. A private cloud is a secure environment located behind a firewall that permits authorized users only. It is designed, built, and operated for a single client, and governed by client's internal or third-party IT team. The advantages of private cloud are that the user has complete control over its data, and this helps avoid security risks. Some disadvantages include all associated costs are paid by the client, since with this control you have to pay a higher cost when compared to public cloud services. It's good for businesses with critical data or high-level security and performance requirements. A hybrid cloud is a cloud environment comprised of 2 or more different cloud deployment models. For example, a cloud user may choose to deploy cloud services processing sensitive data to a private cloud and other, less sensitive cloud services to a public cloud. The result of this combination is a hybrid deployment model. Hybrid clouds can be managed in-house or by an external provider. Advantages of hybrid cloud are it's highly scalable and flexible, giving users the freedom to add or remove capacity or services with varying demand. However, hybrid deployment architectures can be complex and challenging to create and maintain due to its potential inconsistencies in cloud environments. It's good for businesses with security and compliance restrictions that also have a need for low cost and high performance. Community cloud is similar to a public cloud, except that its access is limited to a specific community of cloud users. The members share the responsibility for defining and evolving the community cloud. An advantage is that costs are shared across the group, so those involved get some of the benefits of a private cloud at a lower price. Parties outside the community are generally not granted access unless allowed by the community. In this model, responsibility for governance of the cloud can prove challenging. It's good for joint ventures, research, and other collaborative projects. There are 3 types of service models. The first one is software as a service. It removes the need for organizations to install and run applications on their own computers or in their own data centers. The customer does not need to worry about the management of applications. However, there's no control over data. The second is platform as a service. This model allows to host own custom applications. Users can focus on creating and running applications rather than constructing and maintaining the infrastructure and services. It also focuses on software development of applications. These platforms offer computing and storage infrastructures that help developers create new software more quickly and efficiently. Lastly, infrastructure as a service, in which hardware is provided by an external provider and managed. The client is given access to virtualized components in order to build their own IT platforms. No direct control over the infrastructure, but have the ability to install and manage applications. So who uses it? Software as a service are applications such as Gmail, Trello, Google Docs that are used by end users. Platform as a service are applications such as Heroku, AWS that are generally used by software developers to build software programs. Infrastructure as a service include platforms like Microsoft Azure, Google Compute Engine, which are used by IT teams. Now we will be talking about the cloud computing protocols. In cloud computing, data flow over the internet needs to be secure to prevent leakage of sensitive information. Security is an extremely high priority for cloud computing. Therefore, the team decided to explore the following security protocols, which are Security Socket Layer (SSL), Transport Layer Security (TLS), and Cloud Trust Protocol (CTP). Transport Layer Security provides privacy and data integrity between two communicating applications. TLS possesses high-level encryption and is a more secure version of SSL. TLS resides on the application layer, and it's comprised of two protocols. The TLS handshake protocol, which allows the server and client to authenticate each other and to negotiate encryption algorithms and cryptographic keys before any data is exchanged. The TLS record protocol, which provides connection security. It's also used by cloud services such as Google Drive and Dropbox. Another security protocol that was explored is the Cloud Trust Protocol, a procedure for establishing digital trust between a cloud computing customer and a cloud service provider. Confidence that everything that is claimed to be happening in the cloud is indeed happening. It provides transparency and security to increase confidence and trust. Allows admins to request information about cloud service providers concerning compliance, security, privacy, integrity, and operational security history of service elements being performed in the cloud. Another protocol that was analyzed was the Secure Socket Layer. It provides the secure transmission of documents over a network and creates a secure link between a web server and browser. SSL is a type of socket communication and resides between TCP or IP, requiring no changes to the application layer. It uses Transport Control Protocol for communication and is a slightly modified version of SSL version 3. The objectives of SSL are data integrity, where data is protected. Data privacy is ensured through a series of protocols, including the SSL Record Protocol, Handshake Protocol, and Change Cipher Spec Protocol. The SSL protocol uses standard cryptographic techniques to authenticate the client and server. A HTTP link is secured with SSL protocol and is identified as HTTPS. It's used by most e-commerce sites like Amazon and eBay. TCP Enhanced with SSL not only does everything that traditional TCP does, but also provides critical process-to-process security services, including encryption, data integrity, and end-to-end authentication. To identify that SSL is being used by the browser, the URL begins with HTTPS rather than HTTP. Now moving on to how the SSL actually works. There are three phases of SSL: handshake, key derivation, and data transfer. The handshake involves a client establishing a TCP connection with the server, verifying that the server is actually the server, and client sends a server master secret key, which will be used by both server and client to generate all the symmetric keys that they use for the SSL session. The first part of the handshake is establishing a TCP connection. Host A sends a TCP synchronized packet to host B. Host B receives A synchronized packet. Host B sends a synchronized acknowledgement. Host A receives B synchronized acknowledgement. Host A sends acknowledge. Host B receives acknowledge. And finally, the TCP socket connection is established. The second phase is key derivation. Server and client use the master key to generate 4 keys. EA, session encryption key for data sent from client to server. MA, session MAC key for data sent from client to server. EB, session encryption key for data sent from server to client. And MA, session MAC key sent for data sent from server to client. The 2 encryption keys will be used to encrypt data. The 2 MAC keys will be used to verify the integrity of the data. And finally, the third phase of data transfer. So how does the data transfer work? When the client and server share the same 4 session keys, they can start to send secured data to each other over the TCP connection. To verify the integrity of all of client's data that was sent over the entire session, SSL breaks the data stream into records that consists of type, version, length, and data fields and appends a MAC to each record. The SSL certificate's job is to initiate secure sessions with the user's browser via the SSL protocol. This secure connection cannot be established without the SSL certificate, which digitally connects company information to a cryptographic key. So SSL certificates are an essential component of the data encryption. And here's the process. First, the client messages server to initiate SSL communication. Server sends back an encrypted public key or certificate. Client checks the certificate, creates and sends an encrypted key back to the server. Server decrypts the key and delivers the encrypted content with the key to the client. Client decrypts the content, completing the SSL-TLS handshake. Wireshark was used as a means to understand the SSL protocol better. Google Drive, a cloud computing platform, was run with Wireshark to capture the packets. The first step is when the client starts the SSL communication. We can see the client hello protocol. The client sends a list of cryptographic algorithms it supports, which are the cipher suites in the image provided. The second step, server hello. The server chooses a cipher suite. Server hello protocol is used in the handshake. The third step is the handshake protocol that is used as a certificate. It sends back to the client its choices as well as a certificate. The fourth step is the server key exchange. The server sends its public key and signature as seen in the image. The public key is actually included in the certificate. The client and the server encrypt message with the public key, and it can only be decrypted with the private key. The server never shares its private key with anyone. At the end of the server key exchange, the server sends a server hello done message. Step 5 is the client key exchange. Until now, all the information sent between the client and the server is unencrypted. Now the client receives the server's public key and generates a new session key, encrypted with the public key, and sends it to the server. The session key can only be decrypted with the private key, and because only the server has the private key, the client and server know the session key. The session key is only valid for one session. Using the same key derivation function, they facilitate communication. So what are the benefits of using SSL in cloud computing? Confidentiality. Information exchanged in an encrypted form, creating a safer experience for your customer and protecting both customer and internal data. Reliability. Maintaining message integrity checks, building customer trust and increasing security for your mobile and cloud apps. Authentication. Communication entities identify each other. Encrypt browser to server and server to server communication utilizing HTTPS. Thank you for watching our presentation. We hope you enjoyed.